and gentlemen, once again, a great session with another expert in 3D. Also, just to brief you all, for those who would be visiting this session the first time, I am the managing editor with 3D GRAPHY News, an initiative which is actually taken fold, connecting with the respondents from 3D technology across industries. 3D technology, it consists of 3D printing, 3D visualization, 3D simulation softwares, 3D printable materials, very, very important, ladies and gentlemen, in terms of the right choice, in terms of how this can be printed with various aspects in terms of the technology facilitating to ensure that the final product and the outcome is received and achieved, I would say. And also for institutions who've been actively, who work and support and facilitate this, is also very, very important. So we try and see how we can bridge between the industry, the technology companies, the policymakers, the initiators, all come together and share their insights on the subject to know where the gap is, so that we can try and ensure that it is being meant in the right way for everybody to benefit. So today we have the opportunity to interview Vijay Varda, who is the founder with Fracktal Works, a very dynamic team manufacturing 3D printers. It will be a great exchange of information and for a lot of us to know what this technology and what the company has been doing. Hi Vijay, it's an opportunity to interview you and also to know where it all started, where the journey. So if I can ask you, Vijay, how and why 3D printing?
Interesting story actually behind that. Years back, almost 10, 12 years back, when I was still in college, I had dreams of becoming a robotics researcher, and I was obsessed with building robots, and I had this kida to make. I think my dad also was a doctor, but he keeps telling me that he wanted to be a carpenter. So he sort of instilled that need for creating things from a very young age. So in college, building things as a student is difficult. Not too much money, scrap around pieces of wood and plastic and metal together and do a lot of jugaad and put things together. But that is where I wanted to do better. I wanted to build better. And at that point in time, it felt like CNC machining, injection molding was just sort of big boys' toys, something that you don't have access to. Just around that time, the RepRap movement was picking up steam, which was started by a professor in the US, Adrian Bauer, with the philosophy that a 3D printer can print parts for other 3D printers, and that there were a few sort of stalwarts in that philosophy in India, from whom we sort of bought our first parts, 3D printed parts, to build our own 3D printer. And the goal was to sort of use this machine to build my robots, the things that I wanted to actually sort of work on. And ultimately what ended up happening was, we built our machine. It wasn't that great. I mean, I literally had to sleep next to the machine to sort of get it to print anything. And that sort of took all my time. And I wanted, again, 3D printer also is a kind of robot. So it's sort of my engineering and problem solving brain was sort of an overdrive to get this machine to work better. And I would 3D print upgrades on the 3D printer itself, and sort of just in front of my eyes, the 3D printer itself evolved. Sort of like ship of Theseus, is it the same machine, different machine? A lot of interesting sort of questions came up in my mind when using this technology, because it was so, I felt it was so game changing, where it was almost that, just like you have software updates, where you buy a piece of software and over time it becomes better and better. 3D printing is sort of like that, has a big part of that scalability of software it brings to hardware. You're no longer stuck with that same sort of hardware that you started off with, and a lot of innovation in design can be done. And sort of that is what happened. I fell in love with the technology, fell in love with what was happening in front of me. I was able to build a product and develop it with the same technology itself. Ultimately got to a stage where the printer was printing reliably. I got students and professors from all around the college coming in and getting their fourth year projects done, getting some products made. And that all sort of inspired me to say, hey, this is something that I built for myself and it was supposed to help me, but seems to be that it gonna help a lot more people. And that was really why I got into 3D printing, because it just was such a magical technology.
Yeah, Vijay, now we are at a point where we will need to know how the maker's workshop looks like, because that's where you make your stuff. So if you can just introduce your machines and what all it entails for the making of the final product.
Sure. So this is where we do our job work. We use the machines that we manufacture to make parts for customers across, whether it's sampling, sales samples, whether it's end-use parts. Sometimes customers don't have a requirement for 3D printer because they don't have that many parts that we can produce, but they still have a need for 3D printed parts. So we get that all done over here. So we have an array of both desktop machines as well as our large format, large volume 3D printers over here, where again, depending on the size requirement, depending on the materials that our customers need, we sort of produce all sort of different parts, whether it is sort of medical models, surgery planning models. So for example, this is an interesting model. It's actually a model of a medical screw and how it sort of goes into bone as a educational sample, whether it is for orthopedics, orthotics examples. There's flexible insoles. We primarily do with thermoplastics and FDM technology, and that's what sort of we have here. And we've seen that because of the low cost of materials, low cost of production, it's a great barrier to entry. So it sort of breaks down barriers to entry for customers who have no idea about 3D printing for them to adopt. Because you're not looking at thousands and thousands of rupees or lakhs of rupees to make one model. It is sometimes a few hundred rupees to get a prototype done. And I'd say FDM is a great sort of very functional parts that you can make with FDM, and incredibly strong, incredibly durable. So when you're coming down to using FDM parts for real world use cases, you are putting this into a car, you're making a drone out of it, you are making your parts for say your customized parts for robotic grippers or industrial automation. So FDM parts really work great for that. It might not be the most aesthetic 3D printed technology out there, but it's one of the most rugged, rigid, and functionally strong 3D printed technology out there. The FDM process is fairly simple. Think of it like a hot glue gun, where you have this filament of plastic, sort of looks a little bit like this. This is your thermoplastic, sort of feeds into the pipe, and this is the extrusion head. So the extrusion head heats up to the melting temperature of the nozzle up to about 200 degrees, 250 degrees, and sort of extrudes material out and lays it down layer upon layer onto the bed. So that's how sort of this technology works. And then you have various different spools of material that comes. You have flexible materials, you have flame retardant materials, you have carbon fiber filled material, composite materials. So depending on the end customer's requirement, we would suggest which material is best for them, and then sort of 3D print it.
Also, depending on the application, you can also scale the part. Larger the bed size, you'll get larger
Absolutely.
pieces.
So we have large format prints over here. Say for example, these are parts that we create for industrial customers. So it not only scales in terms of larger size, but the great part of 3D printing is that with a farm of 3D printers, you can print at scale as well. So this is one customer that just needed about 100 components of these. It is too small a quantity for injection molding, but at the same time sort of fits into that sweet spot where 3D printing can be used for economically producing volumes of parts. And this is a part that goes into a shop floor, not needed to have a great aesthetic finish on anything. You're not looking for something that will be there on a shop front, but at the same time it needs to be rugged, rigid, needs to be able to take a beating of whatever happens in the shop floor. So everything is sort of the great technology for that, and per unit cost also is very affordable, which is sort of a big thing if you're looking at affordability of machines and technology in the market.
So, if I may understand now, 3D printing is also now beyond prototyping. Now we are also seeing, 3D printed parts being made and being fitted in assemblies, like you see in drone manufacturing. In aerospace also now we can look at various applications where now you probably need these parts, especially for MRO in aviation industry, these parts might be very difficult to procure or make, because if you had to go through the conventional method, so 3D printing becomes a better option. So what is that Fractalworks can do, and how can it serve each of these industries? Which of the industries currently we are serving, and which all industries we can serve with the technologies, in terms of, if you can really emphasize.
Sure.
Yeah.
So I think that sort of highlights our vision, or my vision for 3D printing. It has to move away, not just move. I mean, 3D prototyping will always be a big application for it, but I like to look at it this way: you are using 3D printing technology for prototyping anyway. You are creating your product. How great would it be that that same technology and process that you use to create your prototype is also what you're using for production? That entire journey that you have to take post prototyping, where you have to figure out your tooling costs, you have to figure out production, you have to figure out supply chain, you have to figure out assembly, create assembly lines, all of that. What if that all of that was already figured out because you already created the prototype, right? It's just an extension of your prototyping process to get to your final part. And because this is the exact process that we take when we are building our own 3D printers, bridge tooling, where before you are able to invest or put in money or be confident enough in your product to put in money in your for injection molding or tooling, you can start production with 3D printing, get your product into the market, get initial feedback. And this is the great thing about 3D printing: you get feedback, tweak the think about software updates. Again, you haven't made any investment in tooling, you haven't made any investment in setting up facilities. The same machine can print your version 1 of your plastic part and version 2 of your plastic part as well. There's just that one machine, the same material. So that philosophy change is sort of drastic when it comes down to how traditionally companies make, and especially with spare parts manufacturing for say just spare parts. If you take as an example the disruptive potential of 3D printing in this. Traditionally, say take an automotive manufacturer, they have to, by law, say 7 years, they have to hold stock components. After 7 years, again, the number of divisions that you need to do, number of new products that you need to do, it's very difficult for an OEM to keep stock of components. And especially if you want to have like a generational faith in your customers, or customers to have that faith in you, you need to be able to give them good service for a long amount of time. How do you do that if you cannot stock spare parts? Imagine that all your spare parts are actually just digital inventory. Everything is just digital, and depending on where the requirement occurs, depending on what are the quantity that is needed, it's produced on demand. This is one of the use cases that we're working with an automotive manufacturer, and over there again, like I was speaking earlier about middleware, right? That we are figuring out that middleware on what it takes to economically produce these parts. What is the technology that needs to happen? What do we need to sort of reverse engineer from the material that needs to sort of fit into the use case, so that economically this will fit in the volumes that they actually require. And this is what I really mean by the back and forth. And this is sort of the formula for success as well. Very rare do I see that 3D printing has been a ready use case that a customer can just adopt it and hit the ground running, apart from prototyping. Especially when it comes down to real world end use manufacturing use cases, there's always that back and forth that happens. And I think that is the biggest value that even we provide as even though we call ourselves manufacturers of 3D printers, I'd say the biggest value add that we have is the relationship that we build with customers to figure out their problems. We want to ensure that our machine actually is being used in your shop floor and workshop, or to do game-changing things, because ultimately this is a technology that has a potential to do amazing things, but unless there's that industry adoption to actually implement and find that value, it won't happen.
So nice to be at your workshop, Vijay. If you can just brief about this, or just take us to this machine, which is actually building, and the bed size. And
so this is one of the machines that we are currently manufacturing. So we are currently in a factory where we produce all of our machines. This is the biggest machine that currently we are making. This is the new generation food extrusion machine that we have, which has two independent print heads, has a large build of volume of 600 mm wide, has capability of printing multi-material, multi-color, as well as independently printing two parts at the same time, because it has two independent nozzles. So you have one nozzle over there, one nozzle over there, and depending on what part it's being printed, so independently the nozzle will come and print. And this is also one of our fastest machines, so we are constantly innovating on how to make the machine faster, more compatible for printing more number of materials, and as well as a lot of ease of use, ease of life changes on making 3D printing more accessible to as many people as possible.
So here is the machines in the making.
Machines primarily goes in schools and colleges, education institutions, and also one of our most popular machines and has lineage from the very first machine that we've started building. Like I said, like one machine built parts for another machine, so this is sort of has lineage to that first machine itself. Some 3D printed parts on this was printed on, was printed on the generation that came after the first machine. So that's very interesting to me. And yeah, so this is where we sort of manufacture all the machines. Right now, a lot of the smaller machines are going to many colleges and schools, where I think that is the interesting. I think this market right now is research education, because a lot of people want to adopt this technology and educate the next generation of students and engineers and researchers on this technology. Hopefully, again, when they transition into industry, we'll see a lot more industry adoption as well.